Welcome, everyone. Thanks for having me today and even opening today's Container Days for manufacturing. I'm really glad to be here, but who am I? So my name is Fabian. I'm Managing Director and lead the area of digital product engineering at Mimacom, and I'm a techie at heart. So for the last years, I've spent most of my professional career building actually platforms. So for the past 10 years at Mimacom, we helped a lot of our customers really build cloud platforms. So we've seen a lot, and I'm just going to share some insights that we have gained over the years, and also what we see as a trend for the coming years. Basically, I want to answer 3 questions. The first one is going to be, what is Kubernetes? As I'm the first one, probably I have to do this a bit for the non-techies in the room. But also, I want to share just a really nice analogy I really use a lot to talk to stakeholders. So even for the techies, it's relevant, because then you can use that actually to ease your conversations with non-techies. Then I want to answer why Kubernetes at all, and finally it's how we actually build Kubernetes platforms in practice. Now, what is Kubernetes? If you check it out, it's container orchestration, and that's 2 words. And if you want to know what it is, then first we need to understand what is a container. And pretty visually, a container is a packaging, right? So we package an application, and similar to a shipping container, we put the code, we put the config, we put the libraries, the services, all of that into a container, and then we are ready to ship this, right? So once we have boxed everything, we put it in there, we are ready to ship this. And now you may wonder, what's the advantage of this? And the easy comparison is the traditional IT. Because in a traditional IT, it more or less looks something like this, right? You have some containerized applications. Some started already doing this, putting them there. Some had some native installers, just unboxing stuff and putting it here, putting it there on a virtual machine. And others used large application servers, just putting stuff in a truck and seeing where it goes. And this is not what we want, right? This is really disorganized. It doesn't scale. And this really helps, understand why is there a need, first of all, to containerize so we can standardize actually on something. And then the question is, of course, how do we scale? And this is by orchestration. Now, when we need a platform, with containers, we can easily scale, right? We can build a huge platform that can take tons of these containers and move them, manage them. And what's relevant then, of course, is, especially for developers, is how to move them. This is the orchestration part, right? So, and Kubernetes exactly does this for us, right? In the IT world, Kubernetes helps us move these containers to the right location, ensures they are in the right spot at the right time, so to say, and scaling IT applications throughout our landscape. And I mean, it's kind of already a bit obvious why this became a de facto standard, but it actually became a de facto standard. I mean, 5 years ago, we were building platforms a lot with Cloud Foundry, and back in the days, no one used Kubernetes in production. Now, luckily, the Cloud Native Computing Foundation has an annual survey, and what's really interesting is that they had almost 1,000 respondents this year, primarily in non-tech companies, and 66% of these respondents said they're using Kubernetes in production. So this really became mainstream over the past years. And now the big question is why in the first place is this being adopted, and why is it actually helping us build better software? And that's what I'm going to quickly elaborate, and then let's see how they actually do this in production. Because still, there's 18%. I'm not sure if we have the same percentage here, but there's 18% still piloting, and 15% actually not using Kubernetes, and they're kind of left behind. But a quick question to the room: raise your hand. Who's using Kubernetes in production at the moment? So there's almost, I would say, a bit more than 66%, which is really nice. And I think I mean, Kubernetes is undeniably becoming the de facto standard in modern IT operations. And that is for 2 reasons. First of all, we get a lot of agility. We can use the same standardized mechanisms to run a whole plethora of different applications, regardless of their size, needs or whatever they have, and it becomes efficient because we use the same techniques and tools. We actually standardize, and that just helps us bringing down costs, right? Now, that's really great, but what do we actually run on this? And I think there's two different things that is very important, because on the one hand, in modern IT, we often with customers build custom software solutions, but that's only part of their IT. And the other part of the IT is like they just buy stuff and they need to run it. And in the past, we had great platforms such as Cloud Foundry that were really optimized on like building and running custom solutions, but they couldn't run off-the-shelf solutions because they had different requirements or other things. And Kubernetes brings this together. So actually, this bridges kind of the gap between flexibility and efficiency. So we get a lot of flexibility, but the trade-off is not that big, and we get a lot of efficiency through standardization. And you can see this basically on Artifact Hub. So an Artifact Hub is a website where you can basically get off-the-shelf software for Kubernetes, and they publish statistics. Here the packages that are available. Like 4 years ago in 2020, they had like not even 2,000 packages that were ready to install. And you can just see the growth, right? It just doesn't stop. And nowadays, they have more than 16,000 packages on Artifacts Hub that you can just go take and install on a Kubernetes cluster. And this just means, as an enterprise, whenever you have a platform, you open a world to a lot of possibilities, right? Because there's already a lot of prepackaged things that you can run on these clusters. Now, to build and run custom solutions, often you don't just need containers, but you also need other things, right? And that is where also Kubernetes has the flexibility aspect of it, in that it is able to really adjust the platform and create a platform that we actually can use. So if you need machine learning, there's answers. You can have custom machine learning stuff on Kubernetes. If you need business process automation, you can install a business process engine there, and you can really make use of Kubernetes as a platform. You can use it for IoT or edge computing. You can add functions to make event-driven applications. So you basically can extend the core of Kubernetes and extend the platform capabilities to just serve different use cases. And that just gives us a competitive edge, right? So we can automate everything in Kubernetes. It's modular. We can just extend it, whatever we need. There's been a lot of effort ongoing investing in security. So actually what we run on Kubernetes can be made secure. It's not a default, right? That comes with flexibility. The trade-off is you need to take care about security. It's not by default, but you can achieve it. And you can actually achieve like a higher level of security than in traditional IT, where just imagine putting all those little things everywhere. That's really, really a pain to manage, right? And through the standardization, it becomes a lot easier. Now, going from theory to practice, the interesting part, right? How do we actually build this platform? And how do you start building really a Kubernetes platform that makes sense for your company? And now, at this point, it's really important that we start talking about not only what is a platform and how do we install it, because you can Google a lot of tutorials, and you can just follow the instructions, the manuals, the documentation is good. But what is really needed to actually run a platform successfully over multiple years? And that is where it comes down to responsibilities. I mean, what are the responsibilities the platform really needs to solve? And taking a look at the responsibilities, there's actually a lot of them that we need to solve, right? So first of all, we need coding, right? To run something, we could buy it, but let's assume we build something, a digital product. We need to code the application. Then we need to think about deployment, right? There's CI/CD we need to take care of, but also like the deployment strategy. Do we need zero downtime deployments? Do we need high availability? All these kind of things. We need to package the application, like putting it into the container, right? You need to build the image. You need to harden it to make sure it's secure. You also need to think about details such as the container operating system. Then for the actual Kubernetes platform itself, you need to think about how do you manage the compute part, there's stuff you need to take care of, such as networking setup. There is compute orchestration, where is like our containers being placed, and it's so sophisticated in Kubernetes, you can basically do everything. But you usually don't want to do everything, right? And then, of course, there's a lot of infrastructure as code choices. You can do Helm, you can do other things. You need to take care about process healing, how are containers being restarted, what happens if the application goes down. Then routing, right? How do we actually get traffic? Also really interesting, right? We need an ingress router. We need to do this. We need service discovery. We have microservices. They need to talk to each other. And it's quite a lot, right? I'm speaking all technical terms here, and it doesn't stop. We need operations. We need to monitor. We need the logs. We need a backup and recovery strategy, like what happens if the cluster goes down? What happens if we need to recover the cluster? What happens if we need to recover the application? And then we need to start talking about security as well, right? In transit with certificates, we can do a lot in Kubernetes to actually have a service mesh and really secure end-to-end the service communication, but also at rest. I mean, we store stuff in file systems. Sometimes if you deploy a database to a cluster, you also need to think about encryption at rest. Then you have access control, who has access to the cluster, who can see what parts of the cluster, which application, and of course you need to put this into a security concept. And that's a lot. That's really a lot that we need to do to get a single application to production. And now, what I find really concerning here is the business value impact. Because the business value impact of all of these activities and responsibilities that we have is mostly over here, right? It's the application itself. The rest has no business impact. There literally is no customer value for end customers if you do any of these black boxes here. For some businesses, it may be that security is like a business impact, but usually it's taken for granted by customers, and no one is going to buy a car because it has the best security, right? Maybe there are some people, I don't want to judge, but usually that's not the number one buying criteria, right? So the business value impact is actually on the left. And now, what do you get with open source Kubernetes? Actually, when you really take vanilla Kubernetes, all you get is a compute orchestration, a process healing, and a little bit of service discovery. And all the rest you need to do yourself. And that is quite concerning, I believe, because essentially, this is really great that we have it, but we need to make a lot of choices to actually get this off the ground and deliver things. And now, what companies started to do is they create a platform team. So they said, oh, this is so much work. For every product team, so we have like 4 product teams, they keep on doing the same things to run the cluster. So we need to centralize this and standardize in a platform team. So they established like a platform team that takes care of running the platform and taking work off the product team so that they can focus really on delivering more business value. And then you usually split these responsibilities, right? So then you have the developer team, they have a certain responsibilities, and you have these shared responsibilities between the product teams and the platform teams. And usually, it's still a burden on product teams. I mean, they want to build features, they want to build apps, and they still need to think a lot about other stuff, but it's already gotten better, like, right? From comparing to the open source one, this already looks better, but of course means also that you need to invest in a platform team that produces no business value, right? So the business value is not the responsibility of the platform team. So this is just a technical, complicated team that needs to be there to make sure the others can work effectively. And that's really interesting because that is where actually there's, I mean, depending on how big this platform team is, either it's really worth it or it's becoming quite a cost factor for companies. And then really the question is like, should we adopt Kubernetes at our company just by looking at this? I mean, it's not obvious, right? I mean, it doesn't seem to make sense just for a single product team to start utilizing Kubernetes as the go-to platform. because there's so many things to take care of. I'm not saying that in other things you don't need to do nothing, right? But you can still make choices where you just reduce the burden and the cognitive load on developers and focus more towards the business value. But also looking at the CNCF survey, I mean, the question is more or less not should we, but when do we start to adapt Kubernetes? Because everyone's using it, there is probably a reason for it. And now the big question is, what's the reason here? There's a really interesting report I like a lot. So McKinsey did a study, and they compared companies with a high developer velocity index. So this is kind of a metric they came up with, how quickly developers are able to deliver value, and compared to those with lower developer velocity index. And this is kind of related to the developer experience, right? So developer experience is a term that we use quite a lot to describe, well, how good we can use platforms and development tooling. And when this is good, usually we are quick to build value. And ultimately, this is what we need, right? And McKinsey found out that companies that have a high developer velocity index, they actually have a 4 to 5 times higher revenue growth compared to companies that do not have a high developer velocity index. They're also more innovative, whatever that means. You need to check the source yourself. But generally, given those numbers, this is really concerning. Even if they only did like SaaS startups and stuff, I mean, 4 to 5x is really a statement. Even if it's just 2x, I mean, it would be worth considering, right? Now, there's just one thing in that developer experience is not Kubernetes, right? So, I mean, Kubernetes is great. Everyone's using it. But just by using Kubernetes, you don't get good developer experience. And now, ultimately, what we want is the developer experience to be right. Because that is where the value is, right? So if we invest in the platform and no one's able to use it because it's so complicated, there is literally no value in using it. The value is being created when the developer experience is good. And now the real question is then, it's like not when do we start adopting it, because that's easy. That's the easy part, right? You can just even go to a public cloud, you can just go click a Kubernetes cluster, but the real question is, how do we achieve a great developer experience on top of Kubernetes? Because that is what ultimately decides the value of the platform itself and the business value that the IT provides to the company. Because, I mean, I'm a techie myself, and I know we're a lot of techies here today, and we love technology, but we can't do things for technology's sake. We need to ensure that the things we build actually deliver value. And now this is the question that has, or a lot of our customers were concerned with, how do we get this right? How do we ensure that we get a great developer experience? And I can tell you there is no golden path to this, but Kubernetes is actually a good starting point for this. And I want to show you why that's the case. Now, if we take a look at what Kubernetes gives us, and let's assume some of these responsibilities we already sorted out. This is like our core platform, right? So we get Kubernetes, we have some ingress, so we get the traffic, there's networking, certificates. We got that sorted out on Kubernetes. We have certificates, service discovery, backup, disaster recovery. Great, we can build applications and put them there. Now, what else do we need, right? What else do we need to add to the platform to make it really usable for developers? And the first category of stuff we need to add is developer tooling, right? So when we see platform teams that are evolving and that start building a real platform that is being used by other developers, they start building developer tooling. They think about, okay, what's going to be the continuous deployment tool? They look at GitOps nowadays. Then you need to take care about continuous integration as well. Then you need to store these things. You have an artifact storage. Once you store them centrally, you can do the vulnerability scanning, but you need to integrate this, right? You can get an open source tool. You can get like proprietary tools to do the job, but you need to get them, pick them, put them there and integrate them in a way that actually makes it easier for developers to use these tools. Because what we've seen is that a lot of companies, what they did in the beginning, I mean, they just bought some cool proprietary vulnerability scanner. They put it somewhere and said, like, look, here it is. Go have fun, developers. You'll do the job. And essentially, it didn't work out, right? So you kind of need an answer on how this is being integrated. And now, once you start doing this, I mean, the more advanced concepts start popping up, right? You can start improving. There's the DORA metrics for a team that actually measures the productivity of teams. You can start building stuff that by accumulating the info we have in all of these tools gives you insights on how good the teams actually perform and gives them a way to self-optimize. Or you can give them a developer portal, right? They can log in somewhere, they get the documentation, they see things, they maybe can create a new project, create something new. And that is where the value starts appearing. And this is not what Kubernetes gives you out of the box, right? This is what you kind of invest in. And of course, we've got some applications here, but only applications so far. And of course, applications need some more things. They need some dependencies at runtime, right? They need some databases. You need to supply databases to the platform. They may need an S3 storage. I'm not talking about file storage, please don't. But like S3 compatible storage. There's message queues you need to talk between microservices. But then also advanced stuff, right? You can use emails. How do you communicate with end customers? You need to send emails, SMS. We have customers that still use SMTP. So imagine like in a Kubernetes environment with like 100 product teams working, and they all build up SMTP connections. Who's doing the layout for these emails? I mean, it really happens today. And I mean, actually, this should be part of a platform, right? You should have an HTTP API, you put the message text, it takes care of the layouting, and it sends it out. But this is something you need to build, and this is not something you can buy, actually. I mean, you can buy email stuff, but actually then you need to integrate it so that your developers can actually use it. And this is where the magic happens, right? Just by buying MailChimp, it won't solve the things. You need to actually integrate it and make it accessible to developers. Now, continuing from here, the journey, we can extend the infrastructure. This is also what happens, right? So the infrastructure team then starts, we need observability. So we have this cool, fancy observability solution. Then some teams start asking, we need functions. So we start adding functions as a service. And of course, you need to take care about firewalls, and you start adding an API gateway on top to handle the ingress and ensuring an additional security layer here. Then you start realizing, okay, our old Oracle identity management doesn't work either, so you start centralizing and doing the customer identity and access management, also connecting that to the platform, ensuring that requests are actually authenticated and have a real session when they reach a microservice, right? Do developers need to do this, or do you have a central platform team that is able to ensure that the requests are actually good when they reach a microservice? There's a lot of things you can do, right? Also, FinOps is becoming a trend now. It's like everyone's starting adopting things, and it's like they do cost, and FinOps is a methodology where you start, providing cost transparency to developer teams, because ultimately what happens a lot is you have big Kubernetes platforms, and the costs are kind of hard to tell. Where are they being created, by which team, by which application? That's becoming hard to track in large platforms. So you need to address this. And then going on, what can you also do with the application? You can add additional, I called it the business automation category. So when you start using technical stuff to actually create business value. There's things such as data streaming. You can add data platforms. So there are data platforms that live outside of Kubernetes. You can buy a lot of hosted ones, but there are also ones that you can actually deploy on Kubernetes, right? You can use open source or proprietary data platforms such as Drem.io that you can actually install on your own cluster. So you could even run your own data platform. If you want to. There's process automation tools that, to orchestrate all these microservices, you need process automation. Then, of course, as we're in manufacturing, you may start looking into how to deploy stuff to the edge, right? Also, AI is cool, and machine learning, and you can add these capabilities also to the platform. And now this gives us a huge landscape. It's a bit frightening. When you look at this, when we started out with Kubernetes, and basically the reason why Kubernetes is so cool is because it enables us to do all these things, but they don't happen out of the box. What happens here is that you need to invest in the stuff and really build the integrations. And now the question is, of course, now knowing what we can do is like, how does this look like in practice? And what actually is a good developer experience? How does a good developer experience look like of a platform? And I brought you an example of a real-world platform that actually has a really great developer experience. And guess what? I took Amazon Web Services, because essentially this is what they do, right? If you look at the map, they do everything. And the interesting part here is that the way they organize things, it's actually convenient, right? You immediately understand it, you have the documentation, you jump to the right service, you just provision it. It just works. And how do typical cloud platforms in companies look like, where we start working with? I mean, I brought an example. This is a Confluence page. It's like the cloud platform. Welcome to the documentation. To get started, take a look at the code. It speaks for itself. And if you have any questions, reach out to John. If he's not available, get in touch with Jane. If they are not available, don't deploy on Friday. Good luck. This is the typical, cloud platform that we face. And I mean, you see the difference, right? And it's like, I mean, I'm not telling you now you start to rebuild the Amazon Web Services in your company, but how do you actually get from this Confluence page to something that actually gives you a little bit more developer experience than what you have today? And that's actually not hard to do. Right? So in one case here, I mean, it starts by just all companies have these things, but they are not centralized. They are not. There's no central ownership on platforms, and that's really a concern. And when you start doing this, you can easily. So this is how we restructured the documentation for a customer, and you can start putting stuff together, right? You can say, like, we get started, we have the onboarding, we have some hosting. Here's the tooling. Like, what do you need to know? There's some blueprints, some snippets, some insights. What's special? I mean, it's not replicating the Jenkins documentation here on CI/CD, right? But it's specifically stating what's different in our own platform as opposed to the vanilla Jenkins that you can just get. And right here you get the blueprints, and it really helps. I mean, it's such a low value investment to build this. I mean, it's not zero, right? You need someone taking care of this, ensuring you get the right. And this is not iteration 1, right? This is some further iteration you have. But this is where you can start investing. And now the question is, of course, like, how do you get started building this? And I think the most important part you have is you have the tech needs. And I think all of us, we always say we need more, but you also have the business need. And you need to manage, like, what's the right trade-off, and not just following all the trends developers want, right? But seeing what are the 80% cases that we can really have a lever and an impact. Now, once you know, like, generally what's the business need, what's the tech need, what are developers complaining about, you can start taking a look at the landscape and seeing, like, from where you are. It's like I call it the heritage IT, because nowadays, like, no one's just in legacy, but they did the lift and shift and just left the legacy in the cloud. So basically, it's the heritage, right? You have what you have, essentially, and you need to start thinking about where do you want to go. So the easy cases are like retain, just don't touch it, and hope-driven, like operations, just hope, or retire, pull the plug. Those are easy. But for the other ones, you need to start thinking about, like, how do you get to these cloud-native application developer platforms? And you can have the 6 Rs, right? You can do a rehost, replatforming, repurchasing, re-architecting, building. That's really great, but you need to do this, right, on a strategic level and think about and identify what's needed. And from there, you can start building out your platform, right? If you understand really what the need is of developers and the IT, then you can start designing the platform. And of course, at some point, you need to, decide whether you want to make or build. And small hint, in manufacturing, in smaller companies, I would say like just buy stuff. You know, it's expensive, but there's good help. There's also like criteria that other companies use to decide for what to buy, and there's different flavors. And in the end, going back to the landscape, it's about iteration, right? You start identifying, so this is an example of a platform that we have in place at customers. This is what they have solved. The other spots that are not filled, they haven't solved. And so they can ask, you know, what do I need next year? What do I need this year? But this evolves. No one has the full platform. And I mean, this is perfectly fine. And yeah, from there, you just iterate and continue, but you traverse the landscape and you extend the platform over time. And yeah, that's how you build it. Thanks for your attention. If you have any questions, we're also around at booth S3 in the corner. Feel free to raise any questions now or later in the breaks, but I'll hand back to you.
Yeah. Thanks a lot, Fabian. So yeah, as he said, if you have any questions, yeah. Thanks for the applause. If you have any questions, please raise your hand and we can go from person to person. I can come maybe.
Thank you. Hi, Morgan, good morning. I'm Praveen here. So with the Kubernetes, the evolution happening from past 10 years, when we see at the landscape what you're presenting, there was a drift where we were moving from on-prem to cloud. Now there is a slight drift again back to on-prem.
Yes.
Especially with the platform as services are coming up and you're providing a lot of stuff. So how do you think in the next coming years, these tools are going to help you as an organization or as anyone who want to have the Kubernetes clusters on-prem back to it? Mm-hmm. So how do you see this development?
Yeah, that's a really great question. I mean, it's like what happens today is that everyone's pushing to the cloud, but everyone starts pushing more to the hybrid cloud, actually. And I think Kubernetes is also a great way, just looking back at the landscape, you can decide here, and this is why I think it's really important to engineer the platform from a central ownership point of view, because you can decide the data platform is something we want to put to the cloud. We will just buy, you know, Snowflake, let it be there, and we have the rest of the infrastructure on-premise. And you can then, of course, start thinking about how do you integrate the different parts and interconnect them. Whether that's a good idea or not, but you can do it. But you could also say, like the data platform as an example, with the DREM.io, you can just run it on-prem, but Kubernetes is the same base. So I would say, you know, Kubernetes is kind of the base of the modern IT, whether you go to the cloud or whether you run it on-premise. But essentially, it's what happens as of now, right? People start doing the hybrid, and hybrid is real. I mean, no company has everything in the cloud or everything on premises, but usually all of the companies nowadays have both worlds. And the key challenge for most teams is the connections are bad. And that's a matter of fact today. But it doesn't need to be this way, right? If you accept the fact that this will be the future, it's going to be hybrid, then you can start investing in exactly building these bridges and ensuring that they actually work out as expected. Hope this answers your question.
Thank you. Any more questions? Yeah.
So, hello, good morning, everyone. My name is Arun, and Fabian, first of all, nice presentation. Looking into this whole platform stuff, I just want your opinion about this platform engineering, like people working in the cultural shift, like from DevOps now more into the platform engineering. They are saying like, okay, DevOps is dead. Someone is saying platform engineering is the future. So I just want to understand from your perspective, at what point a team or a company should look forward for building a platform? Because there can be a scenario that you are happy with how you are doing things with all the automation and the DevOps as in things implemented, and then this is coming as a platform engineer. So should everyone look forward for the platforms and they should build it, or there should be some kind of key factors to consider that now you should build platform, but before that you are good with your DevOps things, whatever you are doing?
Yeah. I think I'm biased to answer this question because I've been building platform for the past decade. But I would say, of course, platforms do make sense, right? The question is, how big does the platform need to be? And I think this is really back to the economics, right? What's the business value of the platform, and what's the cost and the investment cost you have to actually build the platform? And that needs to be balanced, right? You don't need the gold-plated, like full-blown platform in a small company, that's for sure. But what I've seen is that, you know, when you give developers, so we have a customer, they have like 10 development teams. Every team gets access to an AWS account and basically no rules. And imagine how the landscape looks like today, right? So the one is using Fargate, the other one's using Kubernetes, the third one's using serverless, the next one's using I don't know what, and like no team has the same way. So now the key challenge is that when they need new team members, you know, everyone needs to accept that they have like 2-3 months of onboarding time to learn new technologies. If you want to do this, fair enough. It's also a way to approach it, but you know, you can go to the drawing board and like just do the math and see. It would have probably been a good investment in standardizing stuff without compromising flexibility and efficiency. But that's a trade-off, and you can't answer it, of course, easily. But I truly believe that platform teams will be the future. It doesn't make sense, you know, if it happens also to the IT, what happened in other places as well in industries. You start to standardize. Once you have the established standard, it really doesn't make sense to go back unless you have a very, very specific edge case. Also in manufacturing, right? It's the same methodologies that are in place. A lot of things are standardized, like, for example, going back to containers, the containers are standard in size, but if you do some wind turbines, you can't put them in a container, right? And so in that specific case, of course, you may need to build solutions outside of that, and maybe it's even the product teams as a DevOps practice. But going back to the platform teams, I mean, they will be there, and I think for every company it's worth investing in that, if it's technical or if it's just a documentation, and establishing conventions, blueprints, and best practices as a first step. That's also a big value, right? And sticking to them. I mean, not just establishing, but ensuring the transformation goes on, that they are kept up to date. That's an investment. It's not a project, it's a product, right? And of course, the developers are still responsible to run it. I mean, I'm not saying the platform teams will be the future operations team, right? There will still be DevOps people in the teams. But the question is, how much Kubernetes knowledge do you need? Do you need to run the cluster, or do you need to just run stuff on the cluster? And I think that's the difference between platform and DevOps.
Yeah, understand, because the main pain point from my perspective, working as a platform engineer and working on a platform, is more like a shared responsibility that when you are delivering a platform to developers, you need to draw a thin line that, hey, this is what platform is delivering and this is what you need to do. But at another point, if the development team having their own DevOps team, they have the whole control, like, hey, I can say anything to you and you have to do it for me. But in terms of the platform engineering, things are a bit different, because we are working in a standard way, as you said, and we are also working in delivering, like AWS, for an example you showed. They gave us S3, but they just give us S3. It's up to you how to use it. So that's something at some point, a pain point, I would say, the shared responsibility to define a tighter line, I would say, not the dotted one, a solid line, that this is what we are going to do and this is what you're going to do on the developer experience side. But yeah, I understand your point as well. Thank you so much for answering.
Yeah.